Hello everyone, welcome to Schrodinger's Cat and this is Devabrata. Basically, today is our first lecture for the class 11 and 12 JEE Main Advanced and NEET Physics. So, before go ahead our lectures, I just talk one thing that for the exam point of view, basically we summarize the topic and solve the previous year problems for your practice in JEE Main Advanced and NEET. After that we get time and finishing all the topics, approximately 20, we discuss the theory. Basically we have 20 topics for NEET and JEE aspirants. Today we will discuss the gravitation and the most important topics in our NEET and JEE physics, that the current, electricity and heat transfer, electrostatics and magnetism, dimensional analysis, thermodynamics and kinetic theory of gases, waves and sounds, geometrical and wave optics, rotational dynamics, electromagnetic induction, fluid mechanics, and one topic very important, the modern physics. Today we will discuss the gravitation. The subtopics are gravitational force and acceleration due to gravity, gravitational field and potential energy, mechanical energy, conservation and work done, escape velocity, time period of satellites or planets, motion of satellite, Kepler law, and miscellaneous problem. Basically total number of questions are coming for these exams, that in NEET exam, basically in physics the total number of questions 45 and maximum mark that is 180. For JEE Main, the questions in physics, because I basically learn and teach you only physics, the 30 questions weightage 120 marks, and for JEE Advanced paper 1 and paper 2 2 into 17, total 35 questions weightage 100 marks. And in this chapter gravitation there are at most 2 or 3 questions every year. So go ahead our discussions here. So first of all we just discuss the important topics here, that first of all that the Kepler's law. So Kepler's law, basically the first law or law of orbit, and second law is the law of equial areas. So here is a mathematical equation that dA dt is equal to half L by m is equal to constant, where L is the angular momentum about the sun, and the third law is basically the t square is equal to 4 pi square m square a cube L is divided by L square. Basically t square is proportional to a cube, or time periods whole square is proportional to semi major axis whole cube. And we have Newton's law of gravitation, that F equal to G m1 m2 divided by r square, where G be the gravitational constant value 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2, and the acceleration due to gravity is defined as the G me by re square, where me is the mass of earth and re be the radius of earth. and after that the variation in value of G. So if one goes a distance h above the suns, so basically we have the formula here that G dash is equal to G by 1 plus h by Re whole square. So here we G dash greater than G, where this one and M here. So this is the center and mass ME here, that would be Re, and h the distance here. So next, if basically the h less than Re, then the formula goes down that G dash equal to G into 1 minus 2h by Re. So another one, if one goes a distance h inside the earth, this is the outside, and for the inside of the earth, that the result G dash G 1 minus h by Re. So G dash less than G. So its value is maximum at the surface of earth and decreases with increase in height as well as depth. So now go ahead, the next, the gravitational potentials. Basically gravitational field intensity of mass m at a distance r is defined as the E, basically F by m, so gm by r square, and field due to a uniform circular ring at a point on its axis, uniform circular ring, that would become E gmr divided by a square plus r square to the power c by 2. This is a ring and field the distance r. Third one is the field due to a uniform disk at a point on its axis, that would become, for this is for the ring and for the disk we have the result, the gravitational field 2 gmr by a square 1 minus r minus 1 by root over r square plus a square. So next one, basically the field due to a uniform thin spherical shell, for the uniform spherical shell where P is outside the shell, this is a shell, and we have to find the gravitational field outside that point P. We have the formula E equal to gm by r square. When P is inside the shell, the E should be 0 and the graph would like that one, when E proportional to 1 by r square, this is r and this is E. And another one, the gravitational field due to a uniform solid sphere for external point, we have the field value E gm by r square, and for internal point E would become gm by a cube r, and the graphical variation of field with the distance from the center would like that, this is the r and a, so increase linearly and decaying, this type of graph, and this point is a. So Next, the gravitational potential, that the potential due to a point mass, gravitational potential, and for the point mass we have the potential minus gm by r, and potential due to a uniform ring at a point on its axis. This is a ring, we should find the potential at P R, and this is A and O. We have the potential V, first one, that minus Gm by A, where R less than equal to A, inside the cell, and another one Gm by R, where R greater than A, this is for the outside the cell, and the expression is like that: gravitational variations of potential with the distance from the center would become that the graphical expressions here. This is origin and the R, and this is a point. So basically the graph would like that, and this value would become minus Gm by A. So basically here A is the point. So go ahead our next topics, that so basically here just go the another topic, the potential due to a uniform solid sphere for three type, here inside, outside, and the center. So basically for uniform solid sphere, uniform solid sphere, so we have the formula that the potential V is equal to minus Gm by R, where R greater equal to A, and this is a uniform solid sphere, and this P, and this is R, and this is A. So another one minus Gm by 2A cube C square. You just keep in mind this formula, minus R square when R less than A. So at the center of the sphere we just get the value at the center, that minus 3 Gm, this is very important, by 2A. So we just conclude that V center is equal to 3 by 2 V surface. V center is equal to 3 by 2 into V surface, and we have the graph like that. So this is origin, and x-axis would become the R, and x-axis become the potential, and the graph would this one, where this is this bending part cutting, and this is R, and this point is V center, and this is the V surface. So potential energy of a particle placed of mass m and placed at a distance r, center for the earth, would become, this is the potential energy formula, and expression would like that: the U is equal to minus Gme m by r, and at the surface of the earth the potential minus W, minus Gme m by Re. This one is for the at the surface of the earth. So last topic is that energy of satellite. So basically, if a satellite of mass m is orbit near a surface of earth with speed v naught at a circular orbit of radius Re, then the kinetic energy of the satellite is given in the expression. So we have half m v naught square. Kinetic energy is that G m e m by Re. This is the kinetic energy of the satellite, and potential energy would like that U basically minus V by R, and the total energy that E would become the kinetic energy and the potential energy, so minus half V by R. So we have find that the energy of the satellite, kinetic, potential and total, and another one be the escape velocity. The VE escape velocity would become minus 2 VME by RE, where the GME is equal to VRE square, and hence the escape velocity, another one formula where we put GME equal to GR square, we get the 2 VRE, and it implies that the escape velocity does not depend on mass m and angle of projection. And another thing, that for potential energy of a particle of mass m placed at a distance, so basically this figure would like that here this is earth and this is a point here, so basically here is a point A and is B, that one is R, this distance from center, and RE would become this one. So this is the earth. So basically I just summarize the chapter of gravitation. Now go at our important topics and parts, that the problems. So first one, the problem number 1 is coming in basically the NEET questions, saying that the minimum energy required to launch a satellite of mass m from the surface of earth of mass capital M and radius r in a circular orbit at an altitude of 2r from the surface of the earth is what? Coming NEET 2024 recent questions. So solve here. Here is given that the height is basically 2r given, and from surface we have two radius, r1 is r and r2 is 2r given plus r, basically the 3r, and we have to find the minimum energy. So change in gravitational energy, basically we have just write formula, and GMM, first one 1 by r1 minus 1 by r2, and I just advise you that you just pause the video and look upon the questions and think the answers, and after go through the solution we have just doing in our lecture. So just put the value GMM 1 by r minus 1 by 3r, so basically it would become 2/3 GMM by r. So we have the kinetic energy expressions, that EK half mv square is equal to, so find v square is equal to gm by r orbit. So gm by r orbit, and orbit is value 3r, so put here, and the result would become gm by 3r. So we have find the minimum energy. So E minimum, that del E plus G mm by 6r, because we just get the result, put in the value del E, that would become GMM daily value 2/3 GMM by R plus this one GMM by 6R, and we just common here GMM by R, that 2/3 plus 1/6 would become 5/6 GMM by R. So basically the result would become option A, 5/6 GMM by R. So another next problem number 2 coming in JEE Main 2018. So basically this problem saying that a particle is moving with a uniform speed in a circular orbit of radius r in a central force inversely proportional to the nth power of the r. If the period of rotation of the particle is t, then t proportional to what power of r? I just suggest one thing, that we just do 5 important type of questions for JEE and NEET. After we give 5 questions for your homework, and after solving 10 questions and this summary, you just go through this chapter and have a knowledge, and you just clear the exams for a better understanding and concept. So be careful of our problem session. So here given the inverse proportional to basically f is proportional to 1 by r to the power n is given. So f would become mv square by r is proportional to 1 by r to the power n. So here we just get v is proportional to 1 by r to the power n minus 1 by 2. After that, so here 1 by v or is proportional to just inverse n minus 1 by 2. So we have another formula, that time period t equal to 2 pi r by v. So basically t is proportional to r by v. So put r and v, that proportional to r to the power n minus 1 by 2. So is proportional to r to the power 1 plus n minus 2, that would become r to the power n plus 1 by 2. So our final answer would become t proportional to r to the power n plus 1 by 2. D would be the correct answer. So go ahead, our third questions. Third questions is basically question number 3 is basically coming in JEE Advanced 2014, is saying that a planet of radius r equal to 1/10 of the radius of earth and has the same mass density as earth. Mass density is same. Scientists dig a well of depth r by 5 on it and lower a wire of the same length and of linear mass density 10 to the power minus 3 kg per meter on it. If the wire is not touching anywhere, the force applied at the top of the wire by a person holding it in place in given the radius of earth 6 into 10 to the power 6 meter and the acceleration due to gravity of earth is 10 meter per second square. So basically we have to find the force on it. So we have to find the force. So first of all, that given r is 1/10 of the radius of earth, so just write the given data. Our planet, P means planet, is basically RE by 10. Second one is mass density is the same, so mass density is become ME by 4/3 pi r cube, RE cube. Mass density same, so M for the planet would become same, 4/3 pi r planet cube. So here we get that m planet, that would become m earth by 10 cube. So we have formula that g of planet equal to gm by r square. So gm planet by r planet square. Basically that would become the value g here for earth, r means tens, and that would become 10 to the power 3. Just put the value re square and it would become gme by 10 re square, just a minute, 10 r suffix e square, and is like that the g of earth by 10, where it's become the surface of earth. So that the depth of planet, suppose let g depth of planet is equal to depth or surface of planet and become the x by r. So where x is the distance from entire of the planet, x is the distance from the center of the planet, and lambda be the mass per length of that wire. Here saying that lower wire of same length, and lambda be the mass density. Here given the lambda mass density 10 to the power minus 3 kg per meter. So basically for a small segment, that the given df, that would become basically the d, and d small segment of wire, that would denote by d dx gx by r. We just put in this concept, and so after integrate we just get total force F total. So F total become lower limit, basically r by 5, so lower limit would become r minus r by 5 and upper limit r. So here put the lambda dx and the g as usual x by r. So it would become 4r by 5 to r lambda dx gx by r. Now we just put the value here, put this value, and after integrate we just get lambda g by r. So x square by 2 integration and the limit 4r by 5 to r. So after on we just put here the all the values given. So r equal to 1 by 10th of radius of earth, and the another one would become the basically the GE mass density would become 10 to the power minus 3, and put the value of G each for planet GP and R radius for RP, and put the all values and get the result 108 Newton. You just put all the values numerical and put and get the result. The important thing is that in the problem here this is very important. So we just to think the small segment and integrate the total. So 108 Newton be our answer. It is coming in JEE Advanced problem. So go ahead our next problems coming in NEET exam. So it just coming NEET 2021. A particle of mass m is projected with a velocity v equal to kv, where k less than 1, from the surface of the earth, where v is the escape velocity. So you have to find the maximum height above the surface reached by the particle each. Give this velocity v is kv, where v is the escape velocity. This is basically the energy of conservation problem. So first of all, that initial energy would become half mv square, half mv square minus gmm by r, the initial energy, and final energy EF at the maximum height h, final energy EF at the maximum height h would become the final EF half mv square minus gmm by at height h, so basically height, and we just put r plus h. So initial velocity given 0, so half m 0 whole square minus gmm by r plus h. Just calculate and get gmm by r plus h. Now apply the conservation of energy. Initial kinetic energy half mv square, potential energy minus gmm by r, final kinetic energy 0, potential energy minus gmm by at height h r plus h. This is the one equation of energy conservation. Energy conservation. So basically just put value here, put given value v equal to kv. So or by putting half m kv whole square, just v put kv minus gmm by r would become minus gmm by r plus h. So now formula of escape velocity that we write just minutes ago, 2 gm by r, put here. So basically half m k square common, put this value escape velocity 2 gm by r. Now gm by r as usual, and you should calculate very carefully, and after one just we get that k square is divided by r minus 1 by r is equal to minus 1 by r plus h. gmm just cancel out and we get the result, and from that we just get common here the r. So r by 1 minus k square would become r plus h. So now we have to calculate maximum height, so we just common r and get r common here, 1 by 1 minus k square minus 1, so it would become r k square by 1 minus k square. So maximum height h would become r into k square minus 1 minus k square, basically r k square by 1 minus k square. So D would be our correct answers. Go ahead our last problem for the JEE Main 2020. basically it's saying that formally on the x-axis at the distance x from the origin, the gravitational field due to a mass distribution is given by ax by x square plus a square to the power 3 by 2 in the x direction. The magnitude of the gravitational potential on the x-axis at a distance x, taking its value to be 0 at infinity, is what? Basically we have to find the gravitational potentials on the x-axis at a distance x. Basically we have to just find Vx is equal to what? So we have given the gravitational field in the form of ax by x square plus a square whole to the power 3 by 2 and V infinity should be 0. So gravitational potential at x, we just put the value gravitational potential at distance x would become integration V infinity to Vx by the definition dV is equal to gravitational potential definition integration infinity to x field Eg into dx. So just calculate upper limit minus lower limit is equal to minus infinity to x, put this value Eg given in the question ax by x square plus a square to the power 3 by 2 into dx, and just integrate here and integrate here and you get the value, the gravitational potential at point x, a by x square plus a square to the power half. Keep in one point that I don't integrate here because I do it for your homework for better practice, and for your practice I just give homework for this integration, because in your exam you just calculate all the value and the integration and derivative and put the upper limit and lower limit. So for practice purpose I just give you to calculate in the integration and match this result. So basically we have the result, the potential at the point x would become a by x square plus a square whole to the power half. Basically a would be our correct answer. And one thing is that I usually give homework for your better concept and understanding and practice. We have just solved 5 important questions in JEE Main, Advanced and NEET, and for your homework the first of one is given in the NEET exam. Dependence of intensity of gravitational field E of Earth with distance r from center of Earth is correctly represented by. You should choose in one option from the curve. You just pause the video and take a screenshot of my problem, and after solve this problem you just mail me. So second one coming in also NEET exam, the mean radius of the earth is r and the angular speed on its own axis is omega and the acceleration due to gravity of the earth's surface is g. What will be the radius of the orbit at geostationary satellite? Just pause and take a screenshot. Third one, in NEET exam, a satellite is orbiting just about the surface of the earth with period t. If d is the density of the earth and g is the universal constant of gravitation, the quantity 3 pi by 3d represent what? Fourth one, basically coming in JEE Main, just pause this video and take a screenshot. Last one, in advanced questions JEE Main, JEE Advanced, basically a spherical body of radius r consists of a fluid of consistent density and its equilibrium under its own gravity. if PR is the pressure at R less than R, then the correct options is or are. So basically the questions is 1 or more answers are correct. This is basically paper 1 and 2, the JEE Advance, these type of questions are coming, and another one for IIT JAM GATE. This is called basically the MSQ, multiple select question. Basically many answers would have been the correct, either is it 1 and either or it would become the 4. So basically hope to solve these 5 questions, and after one, the last of one is very important, that after solving this homework you just mail cat Schrodinger's 1935@gmail.com without any hesitations. And if you want to need my YouTube lectures, study material, or my lecture note or study material of your NEET and JEE Main Advance only for physics, you just mail in this ID. So last but not the least, thank you, stay happy and goodbye.